Welcome to the next section of the Randomizer project. We are nearing the end of our odyssey of learning about object-oriented programming, and our next big concept is all about another power that object-oriented programming gives us, which is the power to extend objects that we've already written in such a way that we can reuse all or portions of code in those objects. And today we're going to see how we could have written the labeled die in such a way as to use much less code, and in fact to use code that we've already written. So let's see how that works. So first, what we're going to do is we're going to create a new class, and we're going to base our new class off of code that already exists in the form of the polyhedral die, but we're going to make it a labeled polyhedral die. So we're going to call it labeled polyhedral die, which is quite a mouthful, and we're going to click Finish to create our class. Now, in our java.comment, we're going to, whoops, that is not a java.comment. Let's try that again. In our java.comment, we're going to say that we are going to extend the polyhedral die class to include string labels for each side. Okay, and then we're going to, of course, give ourselves credit as the authors of this code and set the version based on the date that we start writing the code. Okay, all right. So we're going to add a new keyword to our vocabulary today, and that is extends. Our labeled polyhedral die is going to extend our polyhedral die class. There we go. So what does that mean? Well, let's do a little investigation. So first, if we type the keyword this inside of a class, actually it has to be inside of the context of declaring something. So let's make it part of, let's add our instance variables and our constructor methods. Okay, so if we put this in the context of our default constructor, labeled polyhedral die, that is quite a mouthful. Okay, so we've got our default constructor here, and if I type the keyword this, and then Eclipse helpfully gives me a list of all of the methods and other assorted things that I have access to. So notice that there's an equals method, but there's also a getCurrentFace method, and it tells me that that comes from the polyhedral die class. Now this is where Java docs start to become important, because you'll notice when I go to the equals method, I get a nice clean Java doc comment, but when I go to getCurrentFace, I don't have anything returned, and nor do I when I get getCurrentValue. So one of the useful things that we really need to start doing is including Java doc comments so that we can access them when we're writing code. It's not just something that you do afterwards for a grade, it actually is helpful. So let's take a step back here and say, let's say that I wanted to write a Java doc comment for my getCurrentValue method in the polyhedral die class. So I'm going to go back to polyhedral die, and I'm going to write a Java doc comment. So what are we going to say about the polyhedral, about the getCurrentValue method? Well, we're going to say that it has a return value, which is the integer value ranging from 1 to the number of sides possible. Okay, and then if I save this and go back to my labeled polyhedral die, and once again type this, and this time I get to go get current value, I see specified by get current value in randomizer returns integer value ranging from 1 to the number of sides possible. So you can see how this can be helpful when you're actually writing code. Okay, so if we look, we can see that I have get current value, get current face, get possible outcomes, and randomize and even toString all listed here. Now, what's not listed here is that I also have access to constructors through a special mechanism. Well, how do I actually call these methods? Well, I can call these methods using another keyword, and the keyword is super. So if I'm calling the constructor for a labeled polyhedral die, I want the first thing that I do to actually call the constructor for a polyhedral die. Now, why do I want that to happen? Because a polyhedral die's constructor does a few things for me automatically. Recall that it will default to having 6 sides, and it will randomly choose a side. Well, what else would my labeled polyhedral die constructor need to do? Well, we know that from the last time that we wrote the labeled die class that we're going to want to have a private string array to keep track of what we're putting on each side. So for this one, we're going to call it our side labels. Okay. So then what do we do in our constructor after we've initialized the number of sides and randomized our die? Well, now we're going to initialize our side labels array. So we're going to say side labels is equal to a new string array. But how many elements do we put into our array? Do I have a method that will tell me how many elements should be in this array? And the answer is, if I type this dot get possible outcomes, doesn't possible outcomes tell me how many possible sides there can be, and therefore how big my array needs to be? Now this keyword is actually optional. We can delete it, and which method is getting called here? Now, is there a get possible outcomes method anywhere in this class? You don't see one. But does it exist? It exists within polyhedral die, which a labeled polyhedral die extends. Now you'll also notice that we didn't say that we're implementing the interface randomizer. So that raises the question, is a labeled polyhedral die a randomizer? And the answer is it is, because we're extending a polyhedral die, and a polyhedral die implements the randomizer class. Therefore, a labeled polyhedral die is both a polyhedral die itself, and it also is a randomizer. All right, so now I have my side labels array created. So now all I need to do is initialize it. So I'm going to say int I equals 0. I is, you know what, we're going to say I equals 1. And say I is less than or equal to, and again, get possible outcomes to find out how many elements are going to be in the array, and then I plus plus. Okay, now because I chose to start with 1 here, what am I going to do here for accessing my side labels array? Well, I'm going to have to say side labels I minus 1 is equal to integer dot toString I. Now you might be wondering, why did I do it this way? Well, I just wanted to demonstrate that in previous examples, we've taken I and we've added 1 here. We could just as easily start with 1 and subtract 1 here. As long as you're consistent, it really doesn't matter which way you choose to go. Okay, so I'm done with my default constructor. It's done all the work it needs to do, and we're ready to move on. Well, what other methods do I need? Well, I need a labeled polyhedral die that takes a string array, set side labels as an argument or as a parameter, and then we're once again going to use our parent's constructor, but in this case, how many sides should my polyhedral die have? And the answer is it should have the number of sides equal to the length of my array. Now, when I call super set side labels, this is an integer, so I'm calling the constructor for the polyhedral die class with 1 integer argument. So what's going to actually get called? Well, if we jump over to polyhedral die here and look at our overloaded constructor, we could see that we have 1 constructor, and what does it do? It sets the number of sides equal to that number and then picks a random number based on the number of sides. So far we're in good shape. What else do we need to do? We of course need to initialize the side labels array with get possible outcomes again. And once again, we want to initialize each of our values in the array, and this time I'm going to show it the other way. So I'm going to do I starting at 0, and I is less than get possible outcomes. I plus plus. Okay, and then I'm going to say side labels I equals set side labels I, and I have now fully initialized my labels array. Okay, well, what's left to do? Well, there's remarkably little left to do, because if you look at polyhedral die, it has a get current value and get possible outcomes method that are already written. All we really need to do is change how get current face works. So we are going to override the get current face method. So how are we going to do that? We're going to say public string get current face, because that's what that method looks like. And then we're going to, instead, we're going to return side labels get current value. Now remember, get current value returns a value ranging from 1 to the number of possible sides. So what do we need to do to turn it into an array index? We need to subtract 1, just like we did up here, which is why I chose to do it that way, so you could see it in more than one case. And then guess what? We are done with that method. That's all there is to it. Okay, well, there's really only one other method that we need to change, and that is we want to change how the toString method works. So we're going to override the toString method inherited, and this is new. We've always inherited our toString method from the object class, but now we're inheriting from polyhedral die instead. So we're going to say public string toString, and then we're going to start writing our code. Now, here's where things get even more interesting. We've already seen the super keyword used in constructors. Now, when you use the super keyword in constructors, there are some special rules. It actually has to be the very first line in your constructor. You're only allowed to do it once, and you're only allowed to do it as the very first thing in your constructor. So it would not work if we move this line to the end here. But you can use super in a different way for non-constructor methods. You can simply call them. So I'm going to return the toString method from my parent by saying super toString, and then I'm just going to tack on. Remember, we wanted the parentheses with the get current value in it added to the end of our string. Well, this is going to get my D and then the number of sides and then the actual current face value, the DN equals, and then the current face value. And then this is going to add on the parentheses. So now we've got some pretty complex code interacting here. Let's see if we can watch it work. So we're going to go back to our DiceBag runner here, and now we're going to alter our DiceBag runner so that we use some of our new dice in place of our older die, in place of the dice we were using. So what I'm going to do first is I'm going to move this sides array up here. And then we're also going to say that we're going to instantiate a labeled die using the overloaded constructor. And then we're going to copy labeled die sides in here. So now we're going to create a labeled die called with side 1, side B, side question mark, side exclamation mark, and side alpha as our first die at index position 0. Then, for our second die, we're going to instantiate a new labeled polyhedral die using the default constructor. So we're going to call this a labeled polyhedral die for our second die. And then for our third die, oops, we can delete that one. We're going to steal that little comment there. Instantiate a labeled polyhedral die using the overloaded constructor down here. And we're going to change that to a polyhedral die. So now I've got one labeled die, which was the one that we created before, and I've got a default constructor labeled polyhedral die and a labeled polyhedral die that uses the overloaded constructor where we specify what's going to be on each side. Now, in order to follow and see what our code actually does, we're going to put some breakpoints in here. So I'm going back to my labeled polyhedral die. I'm going to put a breakpoint on the very first line of code in each of my constructors. And then I'm also going to put a breakpoint in here on my toString method, and let's see if we can follow and see what actually happens here when we run our DiceBag runner. So what we should see is when we get to this line of code right here, labeled polyhedral die, we're going to see the program stop and show us the code. Okay, we're at this line super in polyhedral die. So what's going to happen next is, if I hit step into, I'm going to jump into a polyhedral die because the superclass of the labeled polyhedral die is a polyhedral die. And boom, I'm in the default constructor of, look, of the polyhedral die. And what does it do? It sets the number of sides to 6, then it randomizes, then it's going to return, and now what am I going to do? Now I'm going to create my side labels, and if I go over here and click on this, I can see my side labels here is about to get built. So I'm going to just watch it. You can see those null values over here in the debugger getting filled in with the numbers 1, 2, 3, 4, 5, 6. Okay, now let's just go ahead and resume our code. Where are we going to end up next? Now we're at the labeled polyhedral die, and my side labels are side 1, side B, side question mark, side exclamation mark, side alpha. But what's going to happen here, I'm calling super. And again, what is the super class of the labeled polyhedral die? Well, it's the polyhedral die itself. So here I am. I'm at polyhedral die set number of sides. And what has number of sides just been set to? 5. Then I'm going to randomize, and I'm going to return. Now what's the next thing that needs to happen? My side labels need to get set. So I'm going to go to side labels. And again, now I can see them being filled in, but instead of numbers, they're being filled in with the values for each side. When I'm done, I have all 5. Then I'm going to step out. Then we're going to go down here. Boom, boom, boom. Randomize and dice total and output D5 equals side B2. Now I'm just going to switch back here. I'm going to stop the program. At this point, I'm hoping that you got a chance to see how it called the super constructor within the actual class itself to call its parent's constructor method. So now let's check the output of our program. Here, we'll run it. And notice that the D5 side exclamation mark and D5 side alpha here, they look exactly the same in terms of format. But this one is a labeled die. This one is a labeled polyhedral die. Now, why did we go to all the trouble to make another class that does exactly the same thing as the class we already wrote? Well, let's take a moment here, turn on line numbers. How long was our polyhedral die class? Well, if I delete unnecessary lines so they're about the same, I've got about 42 lines of code there, and here I've got 32 lines of code. And more specifically, if you want to just look, how many instance variables do I have here? I only have 1 in the labeled polyhedral class. In the labeled die, I have... Oh, I was looking at the wrong class. I was looking at polyhedral die. I should have been looking at labeled die. It's even longer, 45. How many instance variables do I have here? I have 2, 1 more than I actually need. And then if I look here, I just have the constructors and then 2 methods. Here, I've got 2 constructors and I've got all these other methods. Now imagine the same example extended to a very large program, and hopefully you can see how much more efficient it is to extend an existing class, and it allows us to do something very important, which is to reuse existing code. Code reuse is a major advantage of object-oriented programming, and what the extends keyword allows us to do.